ASS and CMD.
Okay, so any confusions in the command prompt?
Sir, last 2 points.
Last 2 points. Okay, tell me which command.
Sir, that
Okay.
target.
So let me just open this CMD over here. So task list command, you are having the doubts, right? Okay.
Yes, sir. Task list and trace RT.
Okay. So one thing always you have to know that when we are running our applications, okay, all these applications, what is it needs a process ID to run. Okay. Application is run based on process ID. Okay, means whatever you are running. Okay, for example, right now you can see that I'm running CMD. This is a command prompt. This is an application, right?
Yes, sir.
Yes or no? This is an application. Yes, I'm running Zoom over here. This is another application, right?
Yes, sir.
On it, then it will run, right?
Yes, sir.
All this application, it is run based on what? Based on the process ID. Okay. Now process ID means what? Process identifier. Okay. You know that you are running CMD, but does your system know that you are running CMD?
No.
No, right. So how exactly you can identify the CMD
By
application?
ID. By ID.
Process ID. So all this process ID, how come you can get to know about it? How come you will know that what exactly is the process ID of CMD? What is the process ID of your Zoom, for example? What is the process ID of your browser? How will you come to know about it? This is one you are using which command?
Task list.
Task list. So by using this command, you will get a list of process ID for the applications what is being run on your system. Okay. So when you press enter, this is when it will basically display all the process ID. Now clearly you can see that I'm running over here CMD, right?
Yes.
It is being run over here. Can you see the Zoom?
Yes, sir.
All these are what? What type of file? These are
exe file.
exe means what? Executable.
Executable.
Okay, these are exe files. Okay. So all these exes, whenever you can see that every single application over here, it is having an extension of exe, right?
Yes, sir.
These are all exe files. So all these are programs which is currently being run on my system, and you can see the process ID right over here.
Yes, sir. 10016.
Yes, all these are process IDs. If you see on the top, you can see that this is the process ID column. What is displaying all the applications process ID over here. Now,
okay.
Now, if I want to run an application, let's say that I want to run an application over here directly from CMD. So this is a notepad application. So when I open this application, then a process ID will be created on the system. Yes or no?
Yes, sir.
So this is the application which is opened, and along with it, a process ID is generated. Okay. Now, how exactly I can see that process ID? You can simply just use task list command, right?
Yes, sir.
So press this one, and now you are seeing that the notepad.exe this is having a process
yes,
ID.
Sir.
8616, right?
Yes, sir.
Okay. Now, sometimes like what when you are running multiple applications on your system, sometimes your application it may not respond properly. Like you are clicking and you are seeing that it is not responding. You are trying to close, and this is when exactly what we do. We use Control Alt and Delete, right?
Yes.
And we simply just end the process, right? But this is what exactly we're doing graphically. Graphically, you are doing it. Means using mouse, you're using it, right? But the same thing, how exactly we can do this? Without like what pressing this close button, how exactly we can end this particular process, what is running for this notepad application? This is when exactly you are using which command?
Task list.
Task kill.
Task kill. Okay.
So you are simply just killing that particular process which is running on that application. Okay. So 8616, right? We are having. This is the process ID.
Yes.
Because this is the process ID, what exactly we have to mention. And this is your 8616. That's it. Right. Make sure that you enter the correct process ID over here. Otherwise, you will end up like what? And we are having the success message coming in, right? And the message clearly indicates that the system command, because when we are managing, okay, like what a system, like what in the network environment, we have to open different applications, and sometimes
sir.
like what these applications, it may not respond properly. This is what exactly we don't get the GUI option, this control alt and delete option, it is
Yes,
not
sir.
there. Okay, when you are working in CLI environment, you don't get the control alt and delete option. This is what exactly we are getting this task list and task kill command in order to identify the process of that application which we want to kill it. So simply just
Okay.
use the PID parameter, okay, the process ID parameter, and just list the process ID name, okay, the number over here, and it will do the task.
Okay, sir.
Now, then another command, what exactly we're having, I guess it is the traceset command, right?
Yes, sir. Trace ID.
Traceset. So traceset basically stands for what?
Uh, Trace route is used for troubleshooting network connection related
So
issue using the command.
that is what? Okay, you are tracing the route. So route, you know, right? When I say route,
Route.
yes. So this route means what? Path,
Path.
right? Path information.
Yes, sir.
So how exactly your packet is moving from which device to which device? Because Google server is not connected to your machine, right?
Yes, sir.
You are located somewhere, Google server is located somewhere. Is there any direct connection going from you to the Google server?
No, sir.
No, right? So we are having devices connected in between, right?
Yes, sir.
We have like what routers, we have gateways, which is connecting our network to some other network, then that network to some other network. Like that, you are having all these type of devices getting connected.
Yes, sir.
So when we are talking about like what tracing the path, let's say that this is your PC over here. Okay, which is sending some informations to this particular server machine, which is the Google server. Okay, so this is the Google server over here. Now, how exactly we are having? We are having internet, right? Over here.
Yes, sir.
Over here we are having internet, correct?
Yes, sir.
So we are connected to internet, and this particular server is also connected to internet, right?
Yes.
So in the internet, what we are having? We are having lots of devices like routers,
Yes, sir.
right? We have lots of devices over there,
Which
like
is
routers. Okay, all these devices are there.
So only routers and servers are there.
Routers,
In the
switches are there, but we are considering routers because routers we are using to connect different LANs, right?
internet.
Within a LAN, you can use different devices like switches, you have hubs, you have bridges you are having, but routers mainly is used to connect different LANs together, right?
Right.
So when your packet, when you send any packet, okay, this is your packet. When you are sending it, then first of all, it is going to this router, right?
yes.
Then it will go to this router.
Okay.
Then it will go to this router. Then it will come to this particular router. Then it is getting over here to the server, right?
Server.
So which devices? Total, how many devices it is crossing? This is the first device.
First and fourth.
This is the second. This is the third. Then we are having the fourth
Fourth.
device. So all these devices, they're having their IP addresses, right?
Yes, sir.
All these devices, they're having their IP addresses. This is what exactly you are seeing it. When you give trace, okay, trace cert command, this trace cert basically reveals the IP addresses of the devices which the packet is crossing in order to reach this particular server machine.
Okay.
Getting my point?
Yes, sir.
So all these are basically, you can see it directly because it is visible. Okay, over here you can see that if I simply just give the trace cert command and I simply just give www.google.com over here. So basically what I'm doing is I'm trying to trace the
Path.
path information to this particular server of Google. That is your World Wide Web server. That is
Okay.
basically we call it web server. Okay, it is called web server of Google. So if I simply just want to trace the path to this particular web server, simply just I'm giving this tracer command, and over here you can see that this is the first device. Then we just have to wait because maximum 30 number of devices can basically find the trace. Okay. So all these are basically the number of devices. These are all your IPv6 addresses.
Okay. Yes, I understand.
Right. So clearly you can see that this is the first device. One
Completion.
packet goes first. Then it goes from this device to this device. Then over here it comes. Then over here. Then like this, it is reaching this server over here. So is it exactly the same address what you are seeing over here?
Yes, sir.
Yes, sir.
Right. So this is basically the web server address of Google. Okay, this is your IPv6 address. And when you are getting the same result, okay, the same address over here mentioned, it means the trace is what?
Complete.
Complete. This is what you are having the trace of command.
Okay, sir.
Got it?
Yes, sir.
Okay, so today we are basically discussing about the most important concepts in the basic module, DHCP and DNS everyone. Yesterday we got the reference of DHCP, right? The ipconfig command. Remember? The ipconfig/all, ipconfig/release, ipconfig/renew, right? This switches, what exactly command switches, what we are using, /renew/release. These two commands are basically used in DHCP. So we are basically going to be discussing about what exactly is DHCP, all these things over here. So let me just load the project, everyone. Just hold on. Okay, so here exactly we are having the network, everyone. As you can see that we are having a DHCP server over here. It is connected to this switch. This is your DNS server, which is connected to the switch, and these are two client machines connected to the switch. Very simple network, but we are having very small network. And this is the IP address. Okay, this is a network address actually, and this is what we have the subnet mask of it /24. What exactly is this /24? You will understand it when you will do the advanced networking module. But right now, just think of it like subnet mask. Okay, the subnet mask of the address. We have this particular server available, and this server is doing what? It is simply just giving IP addresses to all these machines. Okay, because this is our main purpose. Okay, the main purpose of using DHCP is to provide IP addresses dynamically to all the systems in the network. Always we are having two methods. Okay, any system, if I talk about any laptop or desktop machines, always these systems can be given IP addresses using two methods. One is a static method, one is a dynamic method. This is the static method where you configure IP addresses manually. Okay, like 192.168, okay, like that you configure IP addresses, then you configure the subnet mask. All these things are manual configuration, you are doing it. So this manual configuration, it doesn't hurt. Okay, it basically consumes time. But if you are having less number of systems, then you can do the configuration. Okay, manually you can configure. Let's say that you are having like what, 5 machines, 6 machines like that. Then you can configure easily. Okay, using this particular static method. Okay, so no issues with that. But when the number of systems are more, let's say that you are having 200 laptops or 300 number of machines are there, and you have to configure IP addresses. Then doing this type of configuration manually on each and every single system, it consumes time. Okay, so time consumption is the main issue because we have lots of things to configure on these 4 fields over here. And each and every single system, it needs to be configured manually when you are using static method. So time consumption is the main factor. When we have a big size network, this is when exactly it consumes time to configure all these configurations, okay, by the network administrator. This is when exactly we are having the DHCP. So when you use DHCP, at the time, all these things, okay, automatically it is given, it is assigned. Okay. Now who is assigning all these informations? This is the DHCP server. The DHCP server will automatically assign all these addresses to the system dynamically. Okay. And it basically takes like what, 1 second, 1 or 2 seconds of time, no matter how many number of machines you are having in your network. All those machines will get their IP addresses via DHCP, like one in just 1 or 2 seconds. It saves time, okay, tremendously. This is what exactly is the benefit what we get when we are using this dynamic method called DHCP to get the IP configuration on our system. So what exactly is required in order to basically get this IP address via DHCP? You need a DHCP server. Okay, this server will be providing the IP address automatically to these client machines. Okay, so why we are calling it client? Because they don't have any IP address, okay, by default. Then by DHCP, they want their IP addresses. Okay, this is why exactly we are calling it client. So obviously server must be there. Otherwise, from whom you will be getting the IP address. So this server always it needs to be configured. Okay, now all this configuration related part is advanced module. Everyone, we will basically discuss about it when you will be coming into the advanced module. But right now, simply just understand the concepts that how exactly everything is working. So this is your DHCP server who is responsible for assigning IP address to systems dynamically in a network environment. Okay, without a DHCP server, you cannot get an IP address by DHCP. So server is must. And the question over here is this: that how exactly this entire like what IP address assignment is taking place, how it is happening. Okay, so this is the process. What exactly is used for that? Okay, it's called DORA process. D for discover, O for offer, R for request, and A for acknowledgement. So DORA basically it stands for what? Discover, offer, request, and acknowledgement. Okay, these are the 4 types of packets. What exactly is used by the DHCP server and the client in order to get their IP address assigned to them. Okay, this is the process. So all these are packets of DHCP. Okay, all these are packet names: discover packet, offer packet, request, acknowledgement packet. All these packets are basically getting exchanged between client and the server in order to get IP address dynamically in a network environment. So for that purpose, DHCP is using port number 67 and 68 UDP transport layer protocol. Okay, you are having one port number is used for sending request, another port number is used for providing replies. Okay, so port number 67 and 68, these are the 2 port numbers always is used when it comes to like what this particular process. Okay, so one for request, another is for providing reply. All this communication, what is done based on client, okay, or between the client and the DHCP server, it is always broadcast. And this one we are using IPv4 global broadcast address of 255.255.255. This is the broadcast address, what exactly is used by client and the server in order to perform this particular process. Okay, this entire process is performed based on this one-to-all type communication. So whatever information this machine is sending it, all the machines they are receiving it. Whatever information this machine is sending it, all these machines they are receiving it. This is what exactly this broadcast address what we are using. So this number of packets, okay, who is sending which packets? This is what is explained over here. As you can see, that we are talking about discover packet. Okay, so discover packet is sent by the client machine to the entire LAN. Means from this machine, a packet will be sent. Okay, it's called discover. And the main idea of sending this packet is to find out who is the DHCP server in the LAN. Okay, because the system, it doesn't know that like what is a DHCP server available in this LAN. So it will discover first, okay, that who among these three machines is this DHCP server. Okay, so whoever is the DHCP server, it will send an offer. Okay, it will send an offer means it will offer an IP address from this network. It will offer an IP address to this client. Okay, because always we are having the network part and the host part in an IP address. So this is a network address, everyone. Okay, and why we are calling it network address, every single thing is like what in the advanced module you will understand it. But right now, just know that this is the network address from this a particular host IP will be provided to this client. Okay, in the offer. So always it is sent from the DHCP server to client. Okay, from here to here it will come. Then the client will be sending a request. Okay, based on that offer, the client will request for that IP address from the DHCP server. Okay, so whatever IP address he is offering, let's say that he is offering this IP address like 192.168.100.3. Okay, let's say that this is the IP address what exactly is offered. So he will be sending a request for this offer back to this DHCP server. Okay, so like what when the DHCP server is offering certain IP address, it doesn't mean that the DHCP server is assigning IP address, okay, to that client. It doesn't mean that. Okay, like what this type of offers can be subjected to like what rejection as well. Okay, means right now he's offering, but later he can also change his offer and he can give another IP address. That kind of offer it is not fixed. Okay, so always this request has to be sent. Okay, whatever IP address was offered by the DHCP server, this client should send a request for that offer back to the DHCP server. Okay, and when the DHCP server receives this request for this IP address, this is when exactly he provides an acknowledgement. Now, acknowledgement always is given based on certain time duration, everyone. Okay, it is what we call lease. Okay, lease means certain time duration. Let's say that this IP address is given to this machine that is for 1 hour only. Okay, so for 1 hour he can use this IP address. Okay, this machine can use this IP address. After 1 hour, what will happen? He has to perform renewal. Means this particular lease duration is over. It means what? That this machine has to again perform the renewal of this lease to the DHCP server. So he will be sending a renewal request over here. If the DHCP server is okay with the renewal, okay, then he will be increasing this duration to, let's say, 2 hours, like that. Okay, so when this renewal request is approved by the DHCP server, this machine can use this IP address for another 2 hours, like that. Always like what this DHCP, it works on these basis. Okay, these addresses are temporary addresses, not permanent address. Okay, no machine can use this type of IP address what they have got by DHCP. Like what permanently. Okay, these are temporarily given IP addresses, and after some time, means after the lease, it is getting expired. Okay, so during the expiry of the lease or before the expiry of the lease, they have to perform the renewal. Okay, so all this renewal always is done by the DHCP server. Okay, and if the server is okay with the renewal, then only they will extend the renewal duration, that is the lease duration, and they will again assign this IP back to this particular machine. Okay, so nothing basically is working without this lease, everyone. Always DHCP is working with lease. Okay, certain time duration. So if you see pretty carefully over here, this is the DHCP server, everyone. Okay, all the configurations already it is being done on this particular LAN. But let me show you the ultimate result, what you are getting. When you are having a DHCP server and everything is working perfectly, then these machines, okay, these are DHCP client machines, automatically they will get their IP addresses from the DHCP server. You can see 192.168.100.4, all these addresses are coming automatically, right? If I simply just show you again, this is your DHCP. See that requesting IP address and you are getting the IP address. How much time it basically took? Okay, like what, 1 or 2 seconds? This is what you are getting the IP address very fast. Okay, assigned to your system. When you have a big network and you have lots of machines to configure IP addresses and all these informations, this is when exactly you are using DHCP. And over here also you are getting the request successful message. Okay, now every single of this machine, they are basically getting their IP addresses. Okay, very fast they are getting it. see that 100.3 is given over here. So the question over here is, what if our DHCP server is not online? Okay, right now you can see that it is online, and that is how exactly they're getting their IP addresses. What if the DHCP server is not online? Okay, so how exactly we can do this? Let me just go to this particular port FS0/0 and let me just shut down this port over here. So as you can see that this particular port is right now red. Okay, it simply indicates that this server is not available anymore in this LAN. So we're having only 3 machines. Okay, these 2 servers and we have clients, and this is the switch which is connecting all these 3 machines together. So right now we don't have any DHCP server. Okay, so what will happen? You can see that this IP address already is designed, so there will not be a problem. But if you again request for an IP, see that the server is not online and you are requesting an IP address. So what we will be getting? See, the DHCP is failed, but instead APIPA is being used. Now, what exactly is APIPA? APIPA basically stands for what? Automatic Private IP Address. Okay, this APIPA. APIPA. Okay, A for automatic, P for private, IP, and last A for address. Now, these addresses are basically considered as link local addresses, everyone. Okay, means you can use these addresses to communicate on a particular link. Means on your LAN you can use it. Any machine you can communicate using this type of addresses, which begins with this range 169.254.0.0 to 169.254.255.55. This is the entire range, everyone. Okay, when you see the first 2 octets of an IP address starts with 169.54, immediately you have to say, okay, or immediately you have to understand that this is something which is related to APIPA. Okay, because APIPA address always starts with 169.254. Okay, it's a class B address and reserved for link local purposes. So link local simply indicates that you are using these addresses to communicate within your LAN only. Okay, let's say that this machine, okay, this machine basically belongs to a different LAN. Okay, this machine belongs to a different LAN over here. Now, from here, okay, from here, if you want to communicate, let's say that this machine, since it is part of this LAN, this machine wants to communicate to this LAN over here. Okay, which is in different LAN. So let's say that it is LAN number 2. So these addresses you cannot use to make communication from your LAN to a different LAN over here. Okay, it is not possible because these addresses are only being used for making communication within your LAN only. Okay. Only within your LAN only you can make communication. Okay, you can communicate to this server, you can communicate to this machine, you can communicate to this particular router using this type of addresses, but you can never communicate from this machine to this machine over here using this type of addresses. That is why exactly we are calling it link local address. Okay. So link local address is nothing but simply the address what exactly you are using to communicate locally. Okay, local communication always you can do it using link local addresses. So if you want to find out that whether we can communicate using these addresses or not, simply just note down the IP address 169.54.70.235. If I go to this machine over here, I can also see that this machine also is not getting an IP address by DHCP because our server is down. Okay, so it is not available. So we'll be getting an API address over here also from the same network 169.254. So what we can do is we can simply just try to communicate. Okay, so this is your 169.254.70.235. This is the machine IP. Okay, this machine IP. So from this machine, if we are sending a ping, we can see that we are getting reply. Okay, so communication is happening without DHCP server as well, because we are getting an IP address, okay, which we can use to communicate locally within our NAT, within our network. Okay, so this is always it is there. Okay, when you have your DHCP server not working, but let me just switch on this particular port over here. So as you can see, this port is coming up. It means this server is right now getting online. So when the server is getting online, this is when exactly all these machines, they will also get their IP address from the DHCP server. So simply just wait for this port to become green, everyone. Right now it is orange. Okay. So still we are getting DHCP failed message. So just wait for this port to become green. Okay, so as you can see that this port is green over here. Now, if I simply just click on DHCP again, so you should see the request is successful. So you can see over here. Okay, we are getting the IP addresses properly, and over here also requesting IP address, we are getting it. Okay, this is what you are having at the DHCP server, everyone. Okay, when exactly you should use it? When you have lots of machines to configure IP addressing configurations. This is when exactly you are using it. Okay, for 2-3 systems. Okay, if you are using DHCP, that is okay, but that is not actually the benefit you are getting. Okay, the main benefit of running a DHCP server, okay, to provide IP addresses to your systems is when you have lots of systems to configure IP addresses. And in companies, always we are getting, okay, like 50-60 number of systems in a department. This is when always we are using DHCP for this. Okay, so this is what you are having the DHCP, everyone. Understood?
Yes, sir.
Any confusions, any questions? Tell me.
Not now, sir.
Okay.
One question I'm having.
Tell me, tell me.
Sir, means how they are deciding that, like, from which class range they have to provide the IP address?
This is the configuration, what you do. All these are configurations, what you are doing on the DHCP server. Okay. And on that configuration itself, you are defining that from which, like what class A address or class B, class C range you want to give IP address to these machines.
Okay, so this you have to configure in DHCP server.
Yes, you have to configure it on the DHCP server. Because
And this,
client-side configuration, you don't have anything, right? You are simply just having this option. Okay.
yes.
So if I simply just use this option, see that client side, there is nothing. You are doing the configuration. You're simply just telling this machine that, okay, take IP address via DHCP from the DHCP server. That's it. Now this client doesn't know, okay, he doesn't know who is DHCP server. So he's starting from discover for request and acknowledgements. Through this 4 process only, this machine is getting their IP address.
Okay.
Okay. Now this is your 2 commands, right? Remember the ipconfig/renew/release command.
Yes, sir.
So if we are talking about ipconfig, can you see the IP address over here?
Yes.
This is the IP address of this machine. This is the subnet mask. This is the gateway address. Okay, gateway. This is your router. Okay, router IP. If you give this ipconfig, okay, /all command. This is when you will be seeing the detailed information. Okay, so ipconfig. Okay, now can you see the detailed information over here? If you compare this command with this command ipconfig, you will see what exactly is different. In ipconfig, you are just getting this much information, right?
Yes.
Only these 4 informations. But when you are using the ipconfig/all command, this is when you are getting what? The DNS server information, the DHCP server information, the DHCP version 6 information, the physical address information. That is physical address means what?
MAC address.
MAC addressing information. So MAC address is found where? Where this
NIC
address
card.
is found?
NIC.
NIC means this is the port, right?
Network interface.
This is the port. This port. This is what type of port we are having.
Fast Ethernet.
Fast Ethernet. You can see that default port we are having. So on the port itself, it is found. Okay, this address. Okay, this port is provided by your network interface card only. Okay, so we are having this ipconfig. Okay, and this is the /all command what we can use. Similarly, you can use ipconfig/release command. Okay, release. Okay, what exactly this release command does is it is simply just releasing the IP address what the system is using. Like all these IP address, the system has got it right from the DHCP server. Yes or no?
Yes.
So if you want to delete all these configurations on this port, what exactly you can do? Release.
Yes.
Now can you see any address over here?
No.
No, sir.
No. So all these informations are like what? It is removed from this port. Now what exactly we can do is we can again request for an IP address using renew. So renew command you use. So see that it is taking some time. Now can you see the address again coming in? This is the same address, right? 100.4 already is given over here, right? And the DNS
Yes.
server. All these informations are given again back to this client. Okay, so release command always you are using to release the IP address what your system is using. So earlier it was using this IP address, it is released. Again, you have requested for a new IP address. Since this address is not used by anyone, okay, in the network, the same address is given back to this machine again. Understood?
This is private IP address 192.168.
Whatever IP over here, it doesn't matter. But the method by which we are assigning IP, it matters. Okay, when we are talking about static, this is a method, right? This is a method by which you are assigning your IP address to your system. But when we are using dynamic, this is again another method, but it is a dynamic process. Automatically, your system is getting the IP address. Whatever IP address, what you are seeing, these are basically you are defining it now. In the configuration of DHCP server, you are telling that from which particular IP, okay, like from which class the address needs to be given. These are basically manually configurable, okay, in the DHCP server. So as a network administrator, you are basically in charge of doing all these things, like which IP address should be like what given when exactly any client is requesting for an IP address. Okay, from which class, okay, it should be given. What is the gateway address? Everything is like what configurable. Understood?
Sir, one thing.
Tell me.
But it means this fast Ethernet is there, default port.
Hmm.
So here I'm getting confused. What is this default port?
Default port means what? This is the only one port you are having on your system by which you are connected to network. That's it.
Means you are
You are
saying
having
this
you,
fast Ethernet means NIC card only, correct?
yes.
Okay. So you mean to say that at present we have only one NIC card. So if there will be two, then
one NIC is giving you only one port. Sometimes NIC card gives you two ports as well. Okay, two ports like first Ethernet 0, first Ethernet 1. You are also getting it like that. Okay, so normally one port that is equal to one port is provided by one NIC card like that. If you have two NIC cards, okay, on your system, then you will be getting two ports. If you have four ports, okay, it means you have four NIC cards installed into your system. Okay, like for example, this type of switch 24, right?
yes.
So every single port is provided by one NIC card. No? So you are having how many NIC cards installed?
24 NICs. So
24
actually,
NICs.
we have 24 other systems, PCs,
24?
and other devices like my laptop and PC client.
I'm not getting you. Tell me
He's saying
clearly.
that he's trying to say that on this switch at a time 24 devices can connect at a time.
Yes. Maximum you can connect 24 devices. If you have 24 laptops or desktops or server machines, okay, or switches, whatever you want to connect, maximum 24 machines you can connect.
Yes.
Okay, sir.
Okay. Any more questions? Everyone taken the screenshot?
No, sir.
Take the screenshot then. In the organization, you are going to see this DHCP. Okay, every single company, they're using DHCP servers because they're having lots of machines, okay, and they want to make this particular process of assigning IP address to systems, okay, automated. Dynamically, they want to do that because it saves lots of time. Okay, the same type of configuration you are doing on every single system again and again and again and again. Okay, this is consuming time. So time management is the main thing when you are doing configurations or when you are managing a big network. In the companies, always you are getting big networks. We have lots of client machines, okay, with whom exactly we are working, okay, and all these configurations, what exactly is required to be configured, okay, if you are configuring it manually, then it will be taking time. That is why exactly you are using DHCP server for that. So within like what 2-3 seconds only, every single machine is getting their IP addresses, okay, and this is what you are getting the benefit.
And sir, one more thing, like you said, the default gateway is our router IP address,
Hmm,
correct?
that is
So
correct.
that will be same for all the machine, that will be part of one, correct?
That is, on this LAN, we are having this particular router which is acting as a gateway. And this is the IP address which is connected on this port. You can see 100.1. This is the IP address of this gateway device on this LAN. It is same for all these devices. On this device
Okay.
also, this device also, this device. It is the same gateway address. It is configured. As you can see over here also, we are having the same gateway address, right?
Yes.
And over here also, we are having the same gateway address. So gateway is not changing because gateway is the device which is connecting your LAN to some other LAN. That is why we are using gateway. Right, because from one LAN to another LAN, when you are communicating, that your information needs to be sent from your LAN to other LAN, right?
Yes.
It needs to be sent. It needs to be transferred. Okay, the information needs to be transferred from your LAN to other LAN, and this is what exactly your router or your gateway is doing. Simply just taking information what you are sending from your LAN, and it
One
is
line.
just delivering it to other LAN. That's it.
Okay. Thank you.
Okay, so everyone taking the screenshot? Anyone is left?
Yes, sir.
Yes, sir.
Yeah,
Okay.
taken.
Now we are coming to this concept called DNS.
सर एक मिनट सर रुकिए एक मिनट रुकिए सर
Both are servers, sir. DNS is also a server and DHCP
Yes,
is
yes,
also
it is a server. It's a server. Both
and it is
DHCP and
present
DNS
in.
is a server. Something. Taken screenshot taken.
ओके
Yes, sir.
Okay, so here we are having the concept, everyone. This is your DNS. What exactly I want all of you to do is draw this particular diagram. Don't take screenshots. If you want to take screenshots, that is okay. But the thing is, I want you to draw this diagram over here. Okay, draw it just the way it is shown over here. Just draw it like that. And just make a heading of domain name system. Okay, this is your DNS.
But it is not clear actually.
You can simply just take the screenshot, and after that you can zoom in and you can draw it. Taken?
No, sir.
So simply just draw it. Write all the things what exactly you are seeing, okay, on the screen as it is. Because this is the concept what exactly we are using currently on the internet, everyone. Okay. The DNS concept. Okay, very popular. It is a very big concept, okay. We are not covering all the things, okay, what exactly is there in DNS. Just the basic information, the foundation level information about DNS. This is what we are discussing because it's a very vast concept, okay. It has lots of things available. So it's mainly a server-side configuration related things, okay. If you are doing the Windows servers or Linux server technologies, this is when exactly we get to know more information about it. But this is a concept what exactly we are understanding, okay, what exactly is DNS and for what reason we are using it. So simply just go ahead and draw this particular diagram. You are having around 5 to 10 minutes of time to basically complete it.